Okay, so today we're gonna be talking about Unreal Insights. I think I said in the last stream we're gonna cover that. So I think today is a good day to do it. I have some time right now, so that should be fine. So we're gonna be using the same project we did before. I just deleted the multi-threading stuff. And I guess the structure that we're gonna go through is first just generally go through the overview of like Unreal Insights, the interface, stuff like that. Then we can go into doing our own custom stuff. So we're just gonna run some code and see kind of the difference between different types of stuff that people do and how you can randomly waste some performance and how you can track what's executed, how long it took, stuff like that. So yeah, I think then let's start with we're just going through what Unreal Insights even are. So Unreal Insights is basically Unreal's profiler from like, I don't even know when did Unreal Insights come. I'm guessing from like 5.0 or 5.1.5.2, something like that. And the general idea is that you just have it always in here. You can pick channels, so basically what do you want to track and what do you want to kind of show. Then you can just start tracing at any point. You even have stuff, so if you go into blueprints and I type insights, you have also stuff in here, so you can start it at runtime, stop it at runtime, so you can do a bunch of stuff. Usually for stuff like this I don't even use it for like start or stopping it at runtime, just because usually it's a bit more intentional. I guess for bigger projects you might want to do like some automatic tracing starting or something when something happens or whatever, or for like some automated tests, but usually it's kind of a bit more intentional where I'm like going into like more optimization mode than like, okay, we're gonna run the Unreal Insights, I'm gonna check a bunch of stuff and then let's see what we get basically. But I do use some stuff in here. So for example, like tracing bookmarks, regions, stuff like that. So we're gonna go through that. I actually haven't used ever the screenshots, but yeah, they also might be useful. But yeah, I just haven't used them. Okay, so let's start. I'm just gonna play the game. I'm gonna start the trace and let's stop it. Pretty simple. So like the startup for trace is really simple. I think before it was a little bit more complicated, but right now you just like literally start, end it, and it just saves it locally. You can open it up. The last one in this list, well, the last one in this list is just what you did last. Basically, it basically tells you my time and basically exactly the date when I did this. So pretty easy to find. And we get something like this. So in here you can have multiple types of profiling. So I can do networking. I think I can do GPU. I forgot, before you had like a GPU profiler that you can access in a different place, but I think you can also do GPU profiling. I haven't tested that, but that might also be a nice thing. But you can also do networking, so you see packets going in and out, stuff like that. You have some session stuff, but usually you won't use it for like simple profiling like we're doing right now. Yeah, so this is the timeline. Whenever you pick a region, it's gonna show in here, and then in here you have like a global general stuff that we're also going to go over. So the biggest thing for Unreal to understand when looking at Unreal Insights, or I guess let's just say architecture of Unreal, is that you have few things to worry about when it comes to like cores and what's being processed. So you have your GPU, which I think lags like 2 frames behind the game thread, or like your current frame. Then you have your RHI, your render thread. Render thread I think lags like 1 frame behind. And then you have your foreground workers, which is usually something I think that you want to sync back into the game thread, so something that you want to happen within 1 frame, but in the background using your other cores or your other threads that are not a main thread. And then you just have background threads that are just like all of your other cores on your GPU basically. So pretty straightforward there. Now we also have timers. So if you have, actually, should we just right away go into events? We could just like create some functions, events, stuff like that. You can trigger them and just like look through stuff. But I guess before we do that, let's go into how you can kind of start debugging your performance issues. So we're gonna kind of look at it more high level, so you don't have to worry about like exactly frame by frame. But usually what we're gonna do is go in here and just generally see who is waiting for something else to happen. So for example, in here, I think our GPU thread is fine. There is like empty space in here, so there is nothing happening here. Our game thread seems fine. Is there any waits in here? So there is something happening here, but not that important. Our ticks are fine. And we have this whole thing in here for slate. And this is just like, this you can kind of ignore for your debugging purposes, because we are in the editor, so you have a bunch of editor stuff. If you want to get more accurate stuff without including the editor, you can also run trace in like a standalone executable, but we're not going to go through that. That's the whole setup there. So yeah, we're not going to be going through that. So, but you can imagine all of this. So for example, in here, 4.7 milliseconds. I'm guessing the UI in the game right now is like half a millisecond or less. Like it's almost nothing, I think. Actually, let's play just to see. Yeah, they have like a small thing at the bottom. They have like a little dot in the middle, and that's kind of about it for the slate. I'm guessing maybe there is like 3D widgets or something, but all of that is not that big of a deal. Yeah, so our tick is fine, and then we can see our try thread not doing much. It's just like interface sending stuff to the GPU, and we can see our render thread is also having to wait a little bit. So that basically means we are probably right now CPU locked. We could even do we have locked frames? Oh no, we don't have locked frames. Never mind. Let me then bring this back. Yeah, so pretty basic stuff. So usually what you do is just see who is stalling, who is waiting for what. Usually if you look, for example, let's pick a frame here. Yeah, sorry, I usually do these like kind of unprepared or unstructured. So I might take some time for some things, but yeah, so you can take a frame and then you can see, for example, if I click on any of these regions, what I can do is click right click and do select time range event, and then you can see that region and what it was doing on other threads. So sometimes when, for example, this region is finished, maybe because it is finished, our array try thread has to do a little bit of things, but then waits, doesn't have anything to do, stuff like that. So when you're trying to trace what is waiting for what, you can kind of see where the regions send, and usually stuff that is waiting for other things is going to be within those regions, so I can kind of see if there is anything being called, but it seems everything is kind of fine. Right now, it's kind of hard to profile like a project that is almost empty, but yeah. So right now, if I was thinking to kind of increase performance, it's probably just the main thread, and it's mostly the, I don't know if I can do, let me actually test this. So if I do standalone, I don't think I can trace right away, because I think I need to set up launch parameters for this, but I don't want to bother with that. That's going to be like 10 minutes. But let's do this thing. I'm just going to quickly do something. Stat FPS. Is it this? I think maybe. I'm just gonna try this. Yeah, you can see now that we removed our slate or our editor UI. You can see how now our FPS is 210, and before when you played in editor it was 140. So that whole thing was on the game thread and it was stalling, or it was like limiting the game thread, basically making it way longer. So now we get unlimited. So now if you look at the profiler, it would probably show that something else than game thread is limiting the FPS, but I don't think I can just start it in here. Yeah, this is going to be for the editor. Let me check. Yeah, I think this is editor. Yeah, unfortunately, I would have to do launch parameters. Launch parameters basically mean that when you like package a game or have like a separate executable, when you kind of run that application can have some rules of what to do when it's being launched, and you can set that up. I think we even have, or not even have, but yeah, we do have launch. It's not in here. I forgot where it is. I'd have to remember this. Maybe it's like... I don't remember. But yeah, you need to set up launch parameters. It might be somewhere in here, like here maybe. Command line options, something like that. Oh yeah, additional launch parameters. Maybe we could, let me actually try quickly. This would be fun if we can do this. Let's just go to GPT. Online join 5, and I need launch parameters to run inside trace. This is what are we playing? We are doing play standalone in editor. Just give me launch parameters as an answer. Let's see. Maybe we can do this really quickly so we can I guess. Would this work? We're gonna try this one if if this doesn't work, we just abandon it, but let's try. Okay. So I'm not sure if it's tracing or not. Let's stop it. I think if... Oh, it was doing something. Oh, it might be tracing actually. Okay. Let's check a frame and see what's happening. Okay, so frame is about 5 milliseconds. That's 200 frames. Okay, I think this is the game. Okay. So let's check out what's happening. Okay, so now that we removed all of the overhead from the editor, we can see how our game thread is now spanning whole 3 milliseconds. So we actually don't have almost anything at the game thread. We're waiting most of it just for something to do. And if you are kind of optimizing your game and you don't know which part of your PC is the bottleneck, you might be like spending a bunch of time optimizing your blueprints, but realizing later that actually my game thread was not doing anything. It was waiting for other stuff to happen. So with this, what we can do is, let's just take a frame. Let's just select the range so we can see it easier. Okay, so our what is this? GPU thread is doing stuff. So our GPU is doing stuff, so it's probably the bottleneck. And our render thread, I don't think it's stalling. Yeah, so this would be our GPU is basically bottleneck now. So if we were optimizing, we would figure out what were the aspects that were taking a long time. So we can see here in the scene is taking like 4 milliseconds. And from that we have render deferred lighting. So this is lumen. So we see reflections. This is just 230 microseconds. Direct lighting, virtual shadow maps. Okay, so virtual shadow maps is taking some frame rate. Let's just then, for fun, quickly disable virtual shadow maps. Or let's do shadow maps. Hopefully nothing compiles. Okay, let's see what happens. Oh, never mind. Now it's even worse. Something else is happening. So virtual shadow maps were actually optimizing something else. So let's not touch it. Actually, let's see. If you play again. Okay, yeah. So virtual shadow maps were actually optimizing something. So when you disable it, you'd probably see even more time taken for just traditional shadows to be rendered. So then we would try to optimize probably like options related to virtual shadow maps. But yeah, so you can kind of see what's happening. We also didn't check the render thread. For render visibility, so this is just like probably all of the objects. Oh no, this is waiting for tasks, so maybe it's something is happening in the background. It's probably delegating tasks for multiple. We can see here like there is stuff executing. Render graph, so this is probably, yeah. So what I'm guessing is our render thread is sending stuff to the foreground workers, and then they're sending stuff back, and stuff is being processed on multiple threads instead of just one. And we can see in here that a bunch of stuff is being delegated. But yeah, okay. So this is kind of how you'd go and just like pick a frame, see kind of who's waiting for tasks, who is not waiting for tasks, what's being processed for a long time, stuff like that. So we don't have to kind of go and actually try to do some stuff in here. But the general rule of thumb is more features, more fidelity usually means less performance, because you just need to do more stuff. Like the most performant level you're gonna have is like the empty level. So as you start adding stuff, it's gonna be more and more. So usually it's optimizing. And usually when you optimize, you have to think about a few things. So you have to think like algorithmic optimization. So just like having better, faster algorithms to do stuff. You can think about caching, batching, stuff like that. Basically doing stuff, similar stuff together, because there is some optimization. We're actually going to go through that, so you don't even have to kind of explain it in theory. You can also think about caching, meaning you just do work once, save the result, and then don't have to do it. And I'm going to actually show you in blueprints what a lot of people do that just destroys your performance for literally no reason. So there is like multiple things that you can do for performance. So before we do that, go to blueprints and start doing some tests. I'm gonna go through time user counters. So first counters, I usually don't even do them. This is just like counting how many things happened. I don't even know if this one is tracing it. Maybe we should pick like a previous trace. The more important is timers, and timers basically tell you what specific region, like these regions here, groups, are doing. So for example, let's just take this 9-eyed draw geometry. So in here we have count, so how many times this section was called in the code. Then we have this inclusive, and this basically means I think this is like in total, so all of the 53 of them in total took 2.8 milliseconds. And then you have exclusive, and inclusive basically means this region plus all of the sub-regions that need to do stuff. So if I have a function and I call another function inside of the function, that whole total time of execution will be calculated inside the inclusive time. And then in the exclusive, the only thing that's going to be calculated is that function, for example, in here, this 9-eyed draw geometry. So only how long that one take, and there is some work being done there, but there is also a bunch of stuff being delegated to some other parts. So just as an example, if you had like a function called function 1, and function 1, the only thing that it did is just called function 2. That function 1 is going to have really, really small exclusive time, because it almost does nothing, it just calls another thing. But if let's say that function 2 that's being called from function 1 has a bunch of work, it does like 100,000 count for loop and does bunch of work, then our function 1, if you look at inclusive for function 1, it's going to be including itself, how long it took to execute, plus the function 2 that was being executed. Hi, USP. Just got performance monitoring system. It hooks Canadian AMD APIs to display GPU stats like VRAM, SC, and blueprints. Oh, that's cool. Yeah, you can also link it. You could check it out. Yeah, that sounds pretty cool. Yeah, so we have kind of the basics here. Let me then close this. We're gonna just put a function. Let's go through some like weird stuff that can happen when we start running stuff. So first, just the most basic thing. Let's do test event. Wait, what? Excuse me. Is okay. Did I misspell this? Okay. So we connect this. Let's not do for loop. Let's do for, or not for each loop. Let's do for loop. So I'm just gonna do the most basic thing, and I'm just gonna show you like one small thing just to see. So let's do sure value into whatever. And we can just do the most basic thing where we just I don't even know. Would we? Let's just do some small math thing. Doesn't matter. So whatever this thing plus this. Let's do 100 of the things. Okay, so let's just save this. I'm just gonna run it normally so we don't have to bother with anything there. Start. Oh yeah, it's not gonna work because it's on the begin play. We're gonna start, then play. Stop. Stop it here. Bam. Bam. So what we're gonna look at is basically what happens when we call kind of a similar thing multiple times. Why can't I find test event? Let me just rename it. Also, it was weird here. Okay, bam, bam, bam. Start, play, stop. So real nice thing is just how easy it is to just start and stop it instead of having to do like going to menus or something. Okay. Bam. Wait, it can't find it. Okay. Am I not calling it? Okay, so the game starts. We have insights here. I mean, okay, everything is working. Okay, let's see. Maybe because of the launch parameters I added, but that would be really weird. Okay, now it's okay. That was weird. Okay, so let's go in here. Oh, actually, then maybe we can do the thing that I said where we check our inclusive exclusive time. So, oh, USP answer. It's not published yet, but I'll send the email. Oh yeah, nice. I'd like to see it. So yeah, let's look what's happening in here. So we have our thingy, and it takes 400 microseconds to run the whole thing. So this function plus all of these little things we did in a for loop. But this function alone to execute takes 2.9 microseconds. So that is basically, if you look at in this graph here, can I do this? I probably have to do Alt F. Yeah, I don't like this program, but unfortunately doesn't work. Other one doesn't work on my PC. So 2.9 microseconds, it's probably like just this area here at the edges that you can see. So it's basically just like the cost of running this function, and it's pretty small, and it actually becomes smaller after you package. I noticed, I think it drops like 2 to 3 times the cost when you package. I think they do some optimizations, nativizations or something. But the interesting thing that a compiler does, like a little optimizations that you get right away, is, for example, let's look at the cost of our functions here. So our less was costing all around like 300 nanoseconds, our add 600. But then when we look at our add and less later, they're way smaller. So basically, in your CPU, you have your L1, L2, L3 cache, and they're like closer to your actual processing units. So that means that they can retrieve information way faster. So the first time you run these functions, they need to get loaded into these caches that are closer to your CPU. But after they're loaded, you can see kind of how it goes way faster. So doing similar things closer together is going to make them run faster instead of just like separating them and throwing them around. This also happens when you do too many like small functions and stuff like that, and you're like redirecting. You're saying like jump here, then transfer it in here, stuff like that. You're basically loading all this stuff in these caches, and then other stuff needs to be loaded out. So you kind of have to, if you want to kind of optimize, and now again we're using blueprints, so we're already trading some overheads for convenience or whatever reason we like blueprints. But you can still get huge optimizations, but not doing some dumb things, basically. Here, I'm not sure what happened. Maybe CPU sometimes gives... is this like syscall or whatever it's called, where Windows takes control of the CPU for a little bit because some other processes are needed, but... Yeah, you can see how later everything is way cheaper because we just loaded it right away and started working on it, and just these two. And if you just like did stuff separately, we just can cure cost because we're like separating stuff. We're not doing like similar stuff like together. So that will be that's called batching, where you just do all of the same things together instead of like separating them. But yeah, and if we click here, can we see? Yeah, so for example, in here, if you look at the inclusive and exclusive time, it's kind of similar. The reason for this is that no other functions are called. We just do math operations inside of this function. So even exclusive is pretty similar because we are kind of doing stuff inside, and there is a bunch of like also empty space. So this is probably like grabbing memories, grabbing stuff from memory. So for example, we are incrementing that one number and that one value. So we're kind of grabbing stuff from there. So that's also a thing to keep in mind there. So now let's go through something that people do and just waste bunch of performance for no reason. Now let me see. Let me see how I want to do this. Let's do it like this. I'm not sure if the compiler is gonna, or like VM, I think is running through VM, so if a virtual machine is going to optimize this this away, but let's try it. So let's do something like this. I'm gonna pick an object in a scene. Sure, this box. This is static mesh actor, okay. I'm gonna add a tag onto it. So I'm just gonna try to make it kind of expensive so it's kind of clear what we're doing. Let's call this tag box. Let's first just test if this works. Get electors with tag. We're gonna do a box. And if this works, we should get number 1 here. Jesus, can I type? Okay, so if this works, we should just get number 1. So let's just test this. We get number 1, that's fine. So let's say we are doing, or let's do 100 loops. and we want to get all actors with this thing, whatever. And we want for some reason to add it to an array. We can make this. Okay, we don't need all of that. We can do then something like this. Yeah, let's make it a bit complicated actually, so we can practically see how we would solve it instead of doing the simplest thing. We can do, sure, something like this. Let's do add. Let's just say we just want 100 times to get all actors with some value. Maybe we change the tag every time, so there's like 100 tags, and for some reason we do this. Let's try to compile and save it. Or no, actually it wouldn't be 100 tags. So let's say, just for this type of optimization, let's say we want to get just a thing, get the same thing. Maybe we are getting like player controller or a game mode or something. And then we just want to kind of put it somewhere 100 times. So let's close this. Let's press start. Let's press play. Close this. Stop it. Let's search for it. Okay. So I'm not sure if it optimized it away, but we're gonna check. Nope. Okay. So in this example, actually no, this is not. Fuck, I should have prepared an example. This is not a good example. But just with this example, first we see the caching that we said before. This function is called the first time. We can see how it took 22 microseconds. And then every time next it took like 6 or 7 microseconds. So I just optimized the way we are doing similar stuff in like a small region of time basically, or right after another. And because we're calling this inside of for loop, we have to do this thing even though we just can get it once. So the simplest optimizations that you can do here is just pull this out of here, and maybe if we want we can store this somewhere, and then for loop we go through that list every time and take it, and then our oh my god, I should have closed it, but we wouldn't be calling these things 100 times because it was inside a loop. But that's a small thing. The more important thing I was thinking about is get actor of class. Let's do something. Oh no, sorry. Get player controller, for example. Should do this. Yeah. What I wanted to show is pure versus impure functions. So every time this is called, it's going to be re-evaluated. So if I call this, let me do something like this. If I call this, let's say 5 times, every time we're gonna get, and this is going to be recalled. But if you have a function that has execution pins, this can be pulled 15 times and it's going to be called only once. So just quickly to showcase this, we're gonna do log string. We don't even have to do it 100 times. Maybe we can just do it once just to showcase this. So this is also one really important optimizations where I see people pull this thing from pure functions like 10 times, and it has to like recalculate it 10 times. So for example, if I have, let's just kind of say we want to log this 3 times. And if you're logging this 3 times, we can do get display name. Oh yeah, we're also getting display name, so that's like a double. That's actually even better. Let's see that. We do this. Let's press start, play. The only annoying thing is that I have to like search like this. There's probably a better way I should find it, but I think I briefly tried googling it and didn't find it. So okay, here is the function. Okay, so log string get. Okay, so we can see the log string takes a lot of time for some reason to just be called once, but then it's called way faster later. But we can see how we need get display name. Actually, our get player controller. Oh yeah, did we optimize that? Oh yeah, I showed it like this. Actually, okay, that's good. That's good. So because we put it like this, so it's just for people, I guess, that don't know. If you create a function, it can be pure or impure, and this basically means if it's going to have execution pins, if it's going to have these pins, just for people that don't know. Yeah, but we can see because we cached this, even though we pull from it 3 times inside of our thing here, because we cached it, we only called it once in here, and then not once later, but because we get display name multiple times and we didn't cache it, we call it here, here, and here. Now for log string, we do have to call it multiple times if you want to do multiple individual logs. But for these display names, so let's do another thing here. Take our display name and do this, because display name every time is going to be the same, so we don't care. But small optimization can just be, let's actually, I will just delete it. Would just be this. Okay. Okay. There must be a better, faster way to do that, but okay. So now you can see our thing here is way more simple. We don't have that stuff in between, so everything is executed faster, and we just get our display name once, we get our player controller once, and we just log once. Now you can imagine if you like just don't ever care about this, you can imagine having like for loop, and this is like, I see this a lot, like having a for loop, and it does a thing, and then it calls some pure functions, let's say like this. So does something like this. Let's say, let's do 100 times, probably less. But you'd have like a function that does this 100 times. And not only we did not cache this one, we didn't even cache this. So then it's called, both of these are called 3 times every time this is called, so 300 times. And we could decrease this to just be called once. If you just cache it in here, we can even do this. We don't even have to cache this because this is just called once for this guy. So we can just literally do this. And now we decrease it from being called 300 times, these 2 nodes, to being called 1 time. So stuff like that you can see all over. And actually, let's even see how much. Now these are pretty cheap, so we are not gonna see like, I guess for something bigger we can see like 1,000. But yeah, let's start. We can leave this one open so we can see the difference. But I'm guessing difference won't be that crazy. But yeah, let's see. Actually, what am I doing? Okay. We can literally just run this twice. We can do this and just bam. Let's name it thingy 2. Bam. Bam, bam, bam. So we can see them right next to each other. We don't have to like do 2 individual traces or whatever. Yeah, this should be fine. So let's press record, play. Now, even if you're like looking at this and you see like microseconds, like 100, 200, 300 microseconds, it's not a big deal. You can imagine in your game you have like hundreds of functions, hundreds of events, stuff is happening all over the place, and you don't want to like stutter or like drop to like 20 frames for a second because some random thing is happening. Thingy. So hopefully we see like noticeable change. Unfortunately, we are not, that function was not, okay, we do see a noticeable change. So we can see that we dropped like 30, or not 30, we dropped a whole millisecond because we didn't, because we did cache, so we can see kind of difference. Can you see it in between? So you can see here we just did it once, we saved it in here, and here you can see it everywhere. It's just like popping up everywhere, and CPU has to calculate it, get it again, get it again, get it again. Now, luckily, there is those optimizations that we talked before, where the first time it's called, it's a bit more expensive, but then it's cheaper. If that is not the case, we'll probably see like double or triple performance save. But stuff like this can creep on a lot, where you can literally lose like 10x performance. Because keep in mind, we're doing like one of the cheapest things, which is like get player controller. But you can imagine you have like an inventory system and you're getting, I don't know, an item, and how you get an item is you go through an array of things, or you have a map and you have to search the map, find item, do some comparisons to check if the item is valid or something. And if we do that 300, and we have like something and we do that 300 instead of 100 times, you could like literally like 10x, 20x your performance cost for that thing. Small optimizations and delete it, and that's it. Not sure exactly what that means, but yeah, what I'm basically saying is, yeah, you kind of do like a small modifications to how you do things. You just need to be aware of, like, when you see a function like this, like what is actually functionally happening. We do a loop, we do a thing, this thing needs some stuff, it needs here, this pure function is going to have to be reevaluated right when this guy needs it. And then this guy asks for the same thing, and this has to be evaluated again. You can imagine like this being saved like this. What this basically means is it's kind of saved locally for this actor, but it's like if I right click and promote a variable, it's the exact same thing. Just like you can imagine if you like saved it as a variable and then use that variable in here. It is the exact same thing when you do like impure function. You just like cleaner sometimes to like have it in here. For this particular thing, you probably don't want to have it like this. Maybe it might be confusing what's connecting where, but so it's gonna make a huge difference. So that's the whole reason why you ever do a pure or impure function. Is pure function basically says, I won't save any state, I won't like remember anything. I just like wherever I'm called, I'm just like I'm a new thing, I'm just gonna be executed. But this guy does it once when you go in, saves it when you go out, and whoever is asking, I could ask this like a second later and we are gonna get a value. It just like saves it in here, and that's about it. Another, for example, thing is, let's say we what could we do? I don't know. Let's say we need to do two things. I guess we don't need this guy anymore. Sure. We went through that example, so we don't care. I know that the player controller really doesn't use location, but just as an example, let's say we need to do two things. We need to save, we need to log something, and then we want to add it to this, sure, let's rename this, to this vector array. When we want to do similar things like this, we want to kind of do it together. You never want to do like, okay, I'm doing this thing, and then after that is done, I'm gonna go in here and we're gonna do this thing in here 1,000 times. The reason why I want to keep everything together is the thing we said with the locality. Just like all of the similar things that need to be done together, it's going to be way more efficient just being done together. But the second thing is your loops cost something. If I double click on the loop, this is kind of what it does. So each of these nodes costs something. It's going to be optimized, of course, when you package, and also some optimizations in the editor when you play, stuff like that. But all of this costs some money, or in this case, performance. And doing it twice, it might not be a big deal. I don't know how much it costs for like 1,000. We could probably see it in here. Can we find it? Let's see. For loop. Yeah, we can find it. Oh, we cannot, never mind. Can we find it? No. Can you just then look at this thing? Yeah, we cannot find it, but basically it's gonna cost something. It's probably not gonna be much. It's going to be like, I don't know, 10 or 20 microseconds for like this loop, and then another 10, 20 microseconds for this loop. But depending on what you're doing, that might be like doubling your performance because you separated something somewhere else. Another thing to keep in mind is functions cost. As we talked about inclusive and exclusive. Exclusive, we can then check. Let me see. Can you actually do... Actually, we can just click here. Okay, what am I clicking? So thingy, bam. Okay, so you can see that this function did not cost much. It's like 1.4 microseconds, but that's again cost. If you're like playing a game, you're gonna be doing dozens or hundreds of functions every frame. So having like this cost multiplied by, I don't know, 100, that might be like 3 FPS less in your game. So just like running small functions and just placing them everywhere cost a little bit of performance. It's not a big deal generally, but if you do stuff like clean code or like stuff like that, where you just like literally put the smallest functions, where you have like doing like the one small thing, that's going to cost you performance, especially in blueprints. In like in C++, it's probably like 1/10 or like 1/100th of this for the cost for a function, so probably not that big of a deal. But in blueprints, you're gonna start feeling it pretty fast. That's one big reason why for loops are so expensive, because you are running this thing 100 times and it costs a little bit in blueprints. So that's kind of the main overhead that you're paying. I have a for loop in actor, then the actor have BP interface with output pin, can this and the actor has a interface. If you're doing interface calls, I think they're generally pretty cheap. I think they're almost as cheap as normal function calls. I think at some point I was doing some checks, and I think it's pretty... So that overhead you probably won't feel that much. The biggest thing with like interface call is just you're like jumping to another part of the code, which might not be a big deal. So you don't want to do like interface calls like in a for loop or something. Usually you want to do it like once here, once there. You're just like kind of calling stuff, but you don't want to just spam it everywhere. But in general, you don't have to worry about too much if they're like more expensive than others. One thing to keep in mind with interface functions is that they cannot be pure. So a good thing about pure functions is that when you call this, it should be a little bit less expensive than having these execution pins. But as soon as you call this twice somewhere, you basically lose that and you start paying more and more. So if you're just calling something once, don't just like make everything impure. That's not kind of the point, especially because you then save it locally, but you probably don't want that in some places. So if you're just doing something once, for example, we have event begin play and I want to do get game mode or something, and I promote it to to save it or begin play. I want to save reference to the game mode. Don't right away do this and connect it. No need to do it if you're just calling it once. But as soon as you call it multiple times, then you get an issue. Especially there is like small things. Wait, what are they called? I think you can find it on map. Let me do something. I think if you do find on a map. Yeah. So whenever you have a pure function like find, and you have two outputs, maybe you want to like, okay, let me find something and if that thing exists, we take the value and we do something with it. That's this kind of like a little trap here where you just kind of do that casually and now you're paying double for find, because it has to find for one connection and it has to find for second connection. So bam, do this, and now you just find once and don't have to do the double cost for no reason, basically. There is like small traps like this that that you can kind of hit in random places. But yeah, let me think, what else do we need to cover? So the main thing is just kind of to give you an idea of how you can use traces to generally get your way around. You can also, yeah, we didn't talk about this. Oh yeah, we didn't talk about a few things. Okay. Another thing to keep in mind is in these timing insights, you have these like spikes, and it just basically tells you how long it took to execute a frame. So for example, in here, it took 200 milliseconds, but the reason is probably I clicked like escape or went away from, like when you press play and I press Windows like this, now it's at like 10 FPS. You can see it in here. So that's the reason for those spikes. But while you're playing a game, you might see some spikes. I'm not sure what this spike is, but you might see spikes, and they even colored it for you, so you can see kind of, hey, this might be something you want to look at, so it's yellow, while this one is red, meaning, okay, this is pretty serious. You just randomly went from like, what was it, like 4 milliseconds to 40 milliseconds. So this might be like something was loading. There's some big for loop that was doing something. Yeah. So you have this graph. We also haven't talked about these options here. Oh yeah, also we have a log. Oh my god, we also have to trace. Oh my god, we spent too much time in blueprints. Okay. So logs, you can also see kind of what was happening each basically millisecond. There's a bunch of stuff that was happening here. This is our for loop, and we see, because we were logging stuff, we can see a bunch of things. And then it becomes more reasonable when we go in here. There's some warnings. This place usually you don't want to spam log. You want to leave it for important stuff. You can also categorize it. What do you want to actually see in the log? Verbosity. So this is, you can look at this like seriousness of errors. So if you're keeping track of stuff, you probably and you want to like fix errors or see stuff, you probably want to start from like here, somewhere here. I don't think we have anything fatal, and probably no errors, but we probably have some warnings. So there is some warning for something. We'd have to check it out, but then display, this might just like let you know thing, hey, I just finished this part of my initialization or something. Then you have a log. It's just like a general log, and very verbose. I'm not sure exactly what that means. Probably just accepts everything here. So this can also help you to see literally play by play. Like if you want to see, okay, what were we actually logging in? What was the thing here? Yeah. Okay, these tracks can be helpful to kind of focus more on things. So for example, you only care about, for example, right now about the CPU, for example, your game thread. So what you can do is just disable your GPU threads. Now game thread is at the top, and we can, I don't know, do we have anything to disable? So array try threads maybe or something. So now you have less clutter and you can just focus on your game thread and see what's happening in here. And the opposite, you can just enable a bunch of stuff so you can see the most accurate view of your whole PC, or like all of your processing units and what they're doing. Okay, I need a drink of water. So yeah, pretty self-explanatory. Similar kind of things in here. There is like timing regions that we're gonna go over, but nothing crazy in here to say. So you have compact mode. If you want to see more things at once, this is more like a vibe view. So you kind of want to see generally how it feels. So for example, in this game, we are not using background threads almost at all. There's like a little bit of work, probably every frame. So you can see at the start of the frame, I think. This is the frame now, so it's at like a middle end of the frame actually. I thought it was start, but yeah. So around middle end of the frame, we're kind of doing a bit of work, but like 95% of our background threads are literally just idling. And unfortunately, by default in blueprints, you cannot do async stuff. You cannot multi-thread. But in the last video, I went through ways that you can throw stuff in the background and fill those background threads up. And you can imagine how much performance you can gain. I mean, for our 1004 loops, we spent like 3 or 4 milliseconds, which is crazy to just throw it on the main thread. But you could throw it on the background thread and go from like 95% empty background threads to like 92% empty background threads. That's how much CPUs today have like empty spaces in other threads that are not like the main one. Even if you have like CPU with only like 8 cores total, that's still like usually like 8 physical, 8 virtual, so that's like 16 threads, and you're already you already have like bunch of more space, even though few of them are going to be so yeah, you have like your render threads, GPU threads, so a few of them are going to be filled, but the rest are just left for you to do whatever you want basically. Okay, so we went through that. Okay, the last thing that we're going to cover is, okay, I don't think we need anything else here. I'm just going to delete stuff. The last thing we're going to cover is just some like manual stuff that you can add to help you with tracing stuff. You could even, maybe there is like plugins for this, or you can create your own like little management system, but what you can also do is trace bookmark. So we can do, let's see, trace book, sure. And also let's do another thing, so we don't make the stream too long. I think we're already like an hour in or something, even more probably. What we're gonna do is trace mark region start, and yeah, so let's we can do next tick, sure. So let's kind of see what this does. So we can do something like this. So the general idea is trace bookmark is gonna give you like a little thing that you can use to more easily figure out where you are in your game when you're profiling, or in like a profiler to see exactly kind of points. Maybe like exactly when the player gets hit, you want to know exactly where that point is in the profiler, so you can use the trace bookmark. And trace mark region is basically going to show you like a region, from one point to the other basically. And you can have multiple regions, stuff like that. So maybe there is like a navigation region, or like AI doing stuff region, or player casting a spell region, whatever. So yeah, let's run this and see what happens. Bam. Okay. So is it called trace bookmark? Okay. So we're gonna right click. Okay. Okay. So when we trigger our trace bookmark, you can see how we now have this little line in here. And however we're zoomed out or where we are, you can see how this trace bookmark just stays in here. So then if you're like zoomed out, you're trying to find what's happening where, you can kind of see the region and find it, and see it basically very easily. Another thing that we added is our traced region. So remember, we started it about the same time. We started in here. And we then said just delay it until next tick. I did not cost this much to delay until next tick, but that's fine. Interesting. So the next tick started after 9.3 milliseconds, and we can just follow the region and find this is the end basically. Is this mark region in? Yeah. So now with that region, you can basically see there is even Unreal regions that you can see. So when we started playing editor, I'm thinking, oh no, start player editor is here. There's some interact, I'm guessing. Is this region from the template I'm using or something else? I'm not sure. Okay, so this is like where we actually started with playing in editor. Loading map, we have the region, how long it took to load the map. So it took like 1/20th of a second. The whole play, I think this is like play in editor. Yeah, okay, so whole play in editor region is 2.3 seconds. So we pretty quickly just started and stopped. And then editor is kind of infinite because it doesn't know it was like abruptly stopped. So it's showing, I mean, I'm not sure why they don't kind of record the last state so they know the time, but yeah, not sure about that. But you can kind of see all of the different regions. So then you can imagine it like opening this instead of like doing this and trying to trace and find a thing. You can just zoom out. Okay, see where are my regions. I don't know, it's over here. We need editor interact. Okay, it's here. We know stuff is happening here. So you can use it kind of in that way. Now our thing was here. Yeah, trace region. So yeah, trace region plus our, where did we have it here? I think. Plus our trace bookmark, you can do stuff like this. That's main thing that I use from this list. You can also get all channels. I don't think we talked about channels, so we can quickly cover it. You also have channels. So what do you want to actually be tracked? So you can see there's a bunch of stuff not tracked in here. For example, if we're debugging Agara stuff, we probably want this. I don't know what thread idle scope means, but there's like a bunch of stuff. It would be interesting to once just like enable everything and see kind of what we get, but I think this is like file loading. So sometimes in Unreal Insights you might see, let's see if you can just find a random place. You might see like an empty region and it feels like, what, are we like just waiting in here, or is this like, even like if you look here, like what, we're not doing anything for like 70-80 microseconds, and maybe if you like try to look below, there is like nothing there. This might just mean that the channel was not recorded. So there is bunch of stuff. There is, unless this is like waiting for something, or like just idling, like the thread doesn't have anything to do. Usually this basically means there is something that's not traced, but there is some work being done here. Like this thing did start, is working on something, but we just don't have it traced. So sometimes if you have like a really specific thing that you want to debug, we have like a general things in here, like your CPU, your bookmarks, GPU, frames. But maybe we want like input, output, time loading. So this is probably more information about like loading your level, stuff like that. Pancake said something. I have a for loop in actor, then the actor has. Oh, this is okay. This is like old comment. Okay. So yeah, there's like a bunch of stuff. I'm not even sure what most of these do, but if you have something really specific that you want to benchmark, or not benchmark, profile, you can just enable it in here and check it out. Now there is a lot of random stuff that I'm not even sure why it's here, like camera system, like not quite sure what that is, but so cook time, this is maybe like when you're packaging the project, maybe you can profile that. I haven't used like everything here, but yeah, there is also a visual logger. We should make a separate video related to, where is it? To this guy. You can kind of visually trace stuff here. Why is it set like that? There's like a fun thing. I'm not sure what profiler would trace from this, but you can basically start this, and then you can have like locations in your level, or like objects that you can trace and place them in here, and then you can visually kind of recreate and kind of go through the timeline, and it's going to show you in your level where the thing was and what happened, stuff like that. It's almost like a primitive version of like sci-fi movies when you're like a detective and you have holograms that like replicate the most likely thing that happened in this crime scene or whatever. So you can kind of create like whole system for that with a visual logger, but that might be again a separate video. But yeah, so I think that's about it. Do we have anything else from here? I don't think I use most of the things. So yeah, this get all channels is just getting like the list of all of those channels. We can get just the enabled ones. You could create like some your own like manager thing, maybe which channels are enabled, maybe giving you like a warning, hey, you don't have this channel enabled and it's good because we have this thing or whatever. Maybe you want like to enforce stuff. But in general, I don't use almost anything else here. Or you can just toggle at runtime. I never use this, but you could create like your own smart thing where if you hit like a weird place in your code, trigger like, okay, I'm gonna toggle my audio channel because we hit a weird thing with the audio issue. I'm just gonna toggle this channel. I'm gonna start tracing, and I'm gonna give like an error to the developer. So then it's gonna pop up an error. It tells you, hey, your audio did a weird thing. We traced the profiling. Check it out or whatever. So you could create like a fancy system for all of this. Usually I don't, just because I usually work on smaller projects, like freelance for people. So usually it's not like I'm working for like a studio of 100 people or something, but there could be like pretty sophisticated software that you can create with this if you wanted to trace. I mean, it's insanely sophisticated already, the whole system, but you can also create your custom utilities and tools to do a bunch of crazy stuff. Do we have to cover anything in here? Yeah, there's some multiplayer stuff, but kill me, I don't want to go into that. So yeah, I think then that's about it. Yeah, I don't think we have anything else, but yeah, it's really important to understand how much a thing costs in blueprints. And if you have like your own component, or even if you have like other, like try to find like if you're using a template or something, just try to profile it and see what the template is doing. 95% of the time, templates and packs and whatever from the marketplace, they're just gonna spam the main thread, and there's gonna be no multi-threading, really low optimization, no caching, no batching, ticks everywhere. So usually I found that you would have like a template with like 5 enemies on a map, almost no thing to do, and you are at like 50 FPS or something. Like you're literally not doing anything, but yeah. So profile, see if there is like any actually good things. That's why I usually just avoid most plugins, templates, whatever, because they're just like set up improperly. So then I would have to do all the optimization. Then I would have to like break down the whole thing so I can kind of reconstruct it in a better way. But why not just create it properly from the scratch that utilizes better the CPU, GPU, and stuff like that. So yeah. But yeah, I think that's about it. Fun stuff. How long did it take? 1 hour and 12 minutes. I mean, better than last time. I think it took like hour and 40 minutes or something. But yeah, that's about it.